Welcome to 7.5. This one's all about similar triangles and indirect measurement. Have you ever wondered how tall maybe a tree is? And there's no really good way to measure how tall a tree is unless you can climb up and drop something down like a measuring tape and hopefully figure out how tall a tree is. So what we're going to work on today is using some triangles with some indirect measurement, and we could figure out how tall a tree is by doing that. Okay, so here's kind of a first example I want you to look at. Indirect measurement allows you to use the properties of similar polygons, what we know to be true about similar polygons, to find distances or lengths that are difficult to measure directly. So one thing that we could do is, this is a Venn diagram, we're not going to do this, but we could measure our arm, and we can maybe find the length of the Statue of Liberty's arm by using indirect measurement, using shadow. And I want to point this one out right here. Okay. Legend says that Thales, who was the first Greek mathematician, he was the first to determine the height of the pyramids by examining the shadows made by the sun. So that's what kind of indirect measurement is using something that we can actually physically measure to find the measurement of something we can't physically measure. So as we look at this, we have this person standing here, and he's holding a stick, and he's measuring. He knows the measurement of the stick, and he can find the measurement of the shadow. Well, because we have the same proportion, the way the sun is hitting the stick and the way the sun would be hitting the pyramid, we would know that this is a 90-degree angle, and the angle that the sun is hitting, the angle of the sunlight, would be the same. And since we know that the angles of these triangles would be congruent. So therefore, if we could find the measurement of the shadow and the measurement of the stick, we could find the measurement of this shadow and use that proportional relationship to find the measurement or the height of the pyramids. So that's kind of what indirect measurement is. And we're going to try to be using that. And I'm going to make it relatively easy. I'm going to try the best I can to make it somewhat easy. And what I want to point out is what we're saying here is something called angle-angle similarity. So if two angles of one triangle are congruent to two angles of another triangle, then the triangles have to be similar. They have to be. They could even be congruent, truthfully, but we know they at least have to be similar. So I can look at this triangle, and I can see visually that this triangle is larger, but I know that the measurement here is equal to the measurement here. These two angles are congruent because of the arcs. That's what they tell me. And then the two arcs here and the two arcs here tell me that angle G and B are also congruent. Well, if these two are congruent, I have to know that the third angle is congruent. Going back to that 180 degrees, so we know that if these two are equal, this one has to be, because of that 180-degree rule. So this is just something that you know. If the two angles are congruent of a triangle, two corresponding angles, then you know that the shapes are similar. Okay, so let's kind of move on down and look at the first example. I want to point out something here. In the figure below, it tells us that angle X is congruent to angle P. Okay, and angle Y is congruent to angle Q. Okay, so if you could extend the sides up of each of these little shapes to form a triangle, you can see that the two triangles are similar. Okay, so triangle similarity can be proven by showing that two pairs of corresponding angles are congruent. You could see, and if we measured the sides, they would be in proportion. So that being said, let's go ahead and look at our first example. And our first example talks about, wants us to determine whether the triangles are similar. If so, write a similarity statement. Well, what they've told us here is that angle E and angle A are congruent, 62 and 62. But angles C and F are not congruent, but we don't know about G and B. So what we need to do is we need to find those missing angles. So what they've done here, angle A and E have the same measure. We already said that, they're congruent. And since 180 minus 62, so we're taking the total triangle degrees of 180, and we're subtracting the two angles we know and finding out what's left over for angle G. So if we do 180, take away the 62, the angle E takes up, take away the 48, the angle F takes up, it says we're left with 70 degrees. So angle G is 70 degrees, which does match angle C. And I bet if we were to do 180 minus 62 minus 70, we would see that angle B is also 48 degrees. So all we're doing here is we're proving that since these triangles have the same measurements, their angles have the same measurements, that EFG is congruent to ABC. Now I want to point out very carefully that E is the 62-degree angle, and it's listed first. And angle A is also the 62-degree angle, and it's listed first. And then angle B is the 48-degree angle, and angle F is the 48-degree angle, and it's listed second. And then angle C is my 70-degree angle, and G is my 70-degree angle, and they are both listed third. So kind of keep that in mind. Order does matter. Okay? So pause the video, try the got it problem below, which is asking us to do the same thing, finding out if these angles are congruent. Okay? Okay, hopefully you've paused the video and you actually tried this. And they only give us one measurement here. They give us 110. So we know that angle H and angle L are congruent. But notice right here we have vertical angles. Don't forget to look for those vertical angles. So we know that angle LKM is congruent to angle HKJ. I can't just say angle K because angle K represents both of those. So HKJ represents, I should say it this way. No, HKJ, the 110, and LKM. I'm starting with the 110 on both of them. HKJ, we can put it to you this way. HKJ is congruent to angle, that looks like an L, sorry, LKM. So since we have two congruent angles, we have similar figures. So triangle HKJ is similar to triangle LKM. Okay? Hope that makes sense. So let's go ahead and let's move on to the next example. Move on to page 555. And on page 555, we're actually going to be using the indirect measurement. And the reason we talked about the angles first is because that's important. The angle that the sun is shining on two objects at the same time would create right triangles. And the angle of the sun and the 90-degree angle are two equivalent angles. And that's what it talked about right here. In shadow problems, you can assume that the angles formed by the sun's rays with two objects at the same location, you can assume that the angles are congruent, especially if they're 90 degrees and they're straight up from the ground. And since two pairs of corresponding angles are congruent, the two triangles, the two right triangles that are created by the shadow and the item are similar. So we can use the properties to find that. So here's what is an example. If we are trying to find this, the height of this street light, okay, it's too hard to measure the street light. But we can see that it casts a shadow. We can measure this along the ground. It's much easier. We wouldn't need a ladder to climb up and figure out how tall this is. So we find something that is near the street light in the same vicinity that we can measure. Well, we can measure the height of the fire hydrant. So the height of the fire hydrant is 2.5 feet, and its shadow is 5 feet. So kind of consider this as the triangle. We're not actually going to use the hypotenuse. We're just going to use the two legs. But we know that they are proportional, because these are in the same angles. We have the angle of the sun, and we have the angle of 90 degrees. So we're going to set a proportion, and it doesn't matter which one you do first. they chose to do the hydrant to the street light. What's important is that if the hydrant is on top here, the hydrant is also on top there. So they combine it by shadow side and height side. Okay? So we have the shadow of the hydrant compared to the shadow of the street light. We make a ratio of those two things. Okay? A reminder that a ratio is a comparison. We're seeing how things compare. We're comparing the shadow of the hydrant to the shadow of the street light. And now we're going to compare the height of the hydrant to the height of the street light, which is what we don't know. So what they've done here is they've done a cross multiplication. It's called cross product. They do 5 times h, and they get 5h. And then they do 26 times 2.5 and get 65. And then we divide both sides by 5. The height of the street light is 13 feet. Okay? So using that, let's go ahead and look at example 3. This one is so weird, okay? But it's not shadows, but we're still using very similar angles. We're trying to look from this point here. We know the distance here, and we know that we're going along a straight line, the very edge of the lake, all the way back, okay? So we're trying to find the distance across the lake. So what we do here is we kind of take the distance across the lake, and we go back to a point that is similar to both of them. So we go from here, and we can see 90-degree angle here, 90-degree angle here. Okay, we're looking at this small triangle right here, and this larger triangle right here. Okay, so look at the larger one, and then look at the smaller one. They both have 90-degree angles, but they both also share angle A. So angle A, we know, is congruent in this smaller one and the bigger one and the 90 degrees. So these triangles are similar. Okay, so we know the distance between A and B is 320, and we know the distance from B to C is 162. So we have to find out the entire distance from A to C. So we would do 320 plus 162. Okay? And find that entire distance. So we're going to do the distance from AB, which is what they did here. And they put it over AC, which is 320 plus 162, which is the 482. This is where they came up with the 482. Okay? Because it's this smaller side of the triangle compared to the larger side of the larger triangle. The hypotenuse of the smaller one to the hypotenuse of the larger one. Does that make sense? So the 320 to the entire hypotenuse of the larger triangle. And then this leg of the smaller triangle, 40, to the leg of the larger triangle, D, which is what we're looking for. Again, cross products, 320 times D, and then 482 times 40. And there's the numbers. They're kind of big, but you have calculators. It's just simple equation solving. If 320 times D is 19,280, we divide both sides by 320, and the distance across the lake is 60.25 meters. Okay, if you need to rewind that and watch it again, please do. There's nothing saying that you can't watch it more than once or take some more notes. Here's our last little problem. I would like you to do the got it, okay? And your answer, you're going to put one answer in this time, but I would like for you to explain how you set it up. So I want you to set up the proportion. So for your 2 points, set up proportion. And solve. So let's help set it up. At the time, a 2-meter street sign, so if you have to draw it, I'm going to draw my little street sign. Here's my little stop sign. Okay, and I know this is a 2-meter tall street sign. It casts a 3-meter shadow. Okay, a nearby telephone pole, let's put it over here. Here's my telephone pole. Okay, my nearby telephone pole casts a 12 1.3 meter shadow. How tall is the telephone pole? So let's call this X. We are looking for the height of the telephone pole. Okay, so X equals height of pole. Okay, I've done that much for you. You set up the proportion and solve for your 2 points today. Okay, and then you guys can compare answers with somebody. And again, I'll always let you fix your answer if you need to. Then your homework assignment is going to be page 557 and 558. Okay, here it is, page 557 and 558. I want you to do 1 through 8 and 11 through 12, or 11 and 12. Okay, there's your assignment. And I will be back tomorrow and we can go over this. But you guys, again, work with a partner. Your goal is to try to get these done the best you can. They're not super difficult, but do your best. I'll see you tomorrow. I've missed you.